Time-lapse is a technique to capture events which are happening slowly, either used for its style alone or to capture things which are entirely impractical to film. The result is much the opposite of slow motion, in that it speeds up whatever is shot to a speed easily distinguished by the human eye. Many cameras today have this function built in, but for those that do not, it can be a hassle to do. There are a lot of hacks around, some involving loading customized firmware onto your camera. But it would be so simple if we only had a timed finger to push the button for us. What if we build our own, using an Arduino and a servo motor? Yeah, let's do that! Aside from the Arduino and a servo motor, you also need a strip of thin aluminum sheet and a few jumper wires. Start by giving the aluminum sheet a bend so at least one of the sides reaches a little bit above the top of the camera. Mount your camera loosely in the tripod and slide one of the sides of the aluminum strip under the camera. Add a piece of blu-tac and fasten the servo temporarily so the center of the shaft of the servo rests a little bit above the button of the camera. Make a mark of the servo position and remove it from the aluminum strip. Take a piece of double-sided sticky tape and affix the servo more securely in place. Insert the horn onto the shaft and manually turn the servo counterclockwise as far as it will go. Remove the horn and reinsert it so it points straight up and screw it in place. This is to ensure the horn will have full range of movement in the final application. Mount the aluminum strip back to the tripod and check for fit. This horn was slightly too short to reach the button on the camera comfortably, so it needs to be lengthened. This is easily done though, just grab some scrap plastic and glue a strip of it to the horn. For added security, drill a couple of small holes and attach a couple of screws to hold it in place. Cut off the lengthened horn so it reaches your button properly. It's also a good idea to add a little bit of cushioning to protect your camera. Just wrap the end of the horn in some thick rubber and electrical tape to make it a bit softer. Next, we hook up the servo to the camera. If you're unsure how, you can look at the servo example on the Arduino webpage. Change the angle incrementally little by little and upload every new iteration to the Arduino board. Stop when you reach just the right level for the servo to trigger the camera. Now you can uncomment the other part of the code and change its servo value to retract the horn. Basically what the code does is to trigger the servo for a short while to take a shot, and then move it away for a longer duration. Fine-tune the first value to make sure it triggers the camera properly. The two delay values in the code make up the final time-lapse interval, meaning that if the first is 2000 and the second is 8000, you will have a time-lapse interval of 10 seconds, as Arduino counts in milliseconds. An updated version of this code can be downloaded in the description of this video. Remember to take into account how quickly your camera can take and save photos so your time-lapse isn't too fast. If the cache memory fills up while shooting, your time-lapse photos won't be in sync. One way to combat that, however, is to shoot to a smaller image size, as then the file size will be smaller as well and will be less likely to fill up your cache. Now gracefully mount the Arduino and camera to your tripod. Set up the camera as you want it and supply power to the Arduino to start the time-lapse. That's it, you're done! It may be rough, but it works. It will work on most cameras, but for some cameras or camera tripod combinations, you may have to figure out your own solution on how to mount your servo. But what if you want something a bit nicer, that you can adjust whenever you want to without reprogramming the Arduino? Here's Timed Finger version 2. To do this, you're going to need a few more parts. Aside from what we used in previous steps, you're going to need a prototyping board, a couple of 7-segment displays, a switch, a push button, potentiometer, and a rotary encoder. You will also need 2 shift registers to control the 7-segment displays, and for aesthetics, a couple of nice knobs. This also uses a smaller Arduino board than before to make fitting into an enclosure easier. I custom made an enclosure on my 3D printer, but you could easily use a pre-made enclosure or even a cardboard box, anything which will contain the parts. I will not go into great detail on how to build this, as what I did was a few levels beyond overkill. A general recommendation when you start a project like this is to start by prototyping the functions on a breadboard to make sure everything works before moving on to the soldering stage. The 7-segment displays and shift registers will need a lot of wires, so avid note-taking not to get things jumbled up is also recommended. Add components one at a time and make sure that each step works before moving on to the next. As this program has 3 different inputs and 2 different outputs, it can quickly become a mess if you don't plan ahead of it. With this many connections, even the schematic becomes horribly complex. You can download a higher resolution of the schematic and a more graphical image of the wiring in the description of this video. So what does it do? At startup, the device, now contained in a nice enclosure, lets you set the exact angle you want the servo to go to, essentially where it will go to trigger the camera. Push once on the button and you can set the duration for the time-lapse interval. Push again on the button and the time-lapse starts running. This will go on until the device is switched off. I won't either go into the programming of this project, but I welcome you to download the Arduino code through the link in the description. The code is commented to understand what each part does, perhaps to a degree beyond necessary. If for some reason your servo won't push the camera trigger, it may be underpowered. The micro-sized servos unfortunately do not have much torque. Should this be the case, just switch to a bigger servo. The steps you need to take are exactly the same. That's it! Happy time-lapsing! If you like what you've seen, be sure to subscribe and consider donating through the Switch and Lever online store to help keeping the channel alive. Thank you! Catch you next time!